While there are a variety of TDR technologies on the market, the two most common types are Pulse TDRs and Step TDRs. This presentation will discuss the basics of how they work and their differences. Pulse TDRs transmit one pulse at a time, wait a calculated time period until no more reflections can be received from that pulse, and transmit the next pulse. Since a single pulse has limited energy, their shortest pulse has a very limited distance for receiving reflections. This requires expanding the pulse width for longer ranges. Doing so expands the dead zone from the TDR's connector along the cable where the TDR cannot see reflections and report events. Other drawbacks to using Pulse TDRs include they must be manufactured to or set to the cable's impedance for best performance and to avoid ghost reflections. They also do not report impedance or loop resistance in actual ohms on the cable or on events. Both readings are important to locate and define events. Faults appear relative in size depending on the pulse width and gain control settings used and the event's detected range. In Step TDR technology, a series of step pulses, generally all the same width, are transmitted in sweeps on the cable. The resulting reflections provide more information about the cable's impedance and events. Key advantages Step TDRs have over Pulse TDRs include no dead zone on any range setting, fault readings displayed with the ohms value to evaluate the fault's size and service impact. Cable's impedance reading and its loop resistance are shown over the cable's entire length. Step TDRs have clearer fault indications, and no pulse width or gain control to alter the appearance of the faults. This slide contains examples of Step TDR traces. Starting on the left are good splice and twisted pair cable. Even a good splice will show some reflection due to the wire pairs separation required to perform the splice or connection. A good coax splice or barrel connector done properly will generally not show any reflection. Bad splice has two faults, too much untwist and a series resistive fault. One or both conductors are corroded or dirty and not making a 0 ohm connection as shown by the trace exiting the splice slightly higher than it entered the splice. Mixed impedance cables show up or down steps in their trace. Water always shows an erratic downward change in impedance. When the water ends, the trace returns to normal impedance. Water also reduces the wet section of cable's velocity factor to some unknown value, so distances in and after the water are not reliable. Bridge tap. When a drop cable, either twisted pair or coax T, is added to a main line, the tap will show at about half the impedance of the main line over the length of the tap. This is due to the reflections from two similar impedance cables being received by the TDR at the same time. Split pair. This occurs in twisted pair cables with multiple pairs and is induced at connections or splices. One wire from one pair becomes crossed with one wire from an adjacent pair. The signals on these split pairs is now traveling on separate wires, which will have a higher impedance than the paired wires. If the split is corrected at a different location, referred to as a resplit, the impedance of the pairs will return to normal. Pinch coax will show a downward dip in impedance. Poor quality center conductors in coax cables will show excessive loop resistance or dribble up in the trace. Gauge changes. These are common in telecom outside plant cables, and they are easy to spot with a Step TDR. Larger gauge wires have a lower loop resistance and a flatter trace. Conversely, smaller gauge wires have a higher loop resistance and a more pronounced dribble up in their trace. When comparing what a Step TDR can display about a cable to a Pulse TDR, there's a clear difference. Step TDR technology is far superior in performance. Thank you for watching. If you're interested in finding out more about all the capabilities in our E2020 Step TDRs, see the next two video series on the TDR's menus and functions, or contact us at AEA Technology.